Hey everyone, I'm Greg from Oxen AI, and I'm here to give you a quick 5 to 10 minute demo of what Oxen AI is, how you can integrate it into your data workflows, and give you a real world example of why data version control is important. So if you'd like to follow along, you can go to docs.oxen.ai, and we'll also be going through this blog post at blog.oxen.ai called Data Version Control 101 with Oxen. So what is Oxen? Oxen, at a high level, is a lightning fast data version control system for structured and unstructured machine learning data sets. But what does that actually mean? So diving over to the blog post, Oxen has developer tools that software engineers, data scientists, machine learning engineers can use, and then a web interface where all of those people, plus their managers, plus other data stakeholders can log into, view the data, view the changes over time. It's very similar to the Git and GitHub split, but we'll see where the workflows diverge as we go through this tutorial. So one question might be, why version data in the first place? And if you're new to version control, this might be eye-opening. If you've version controlled your code before in Git, feel free to just bear with me for a few seconds here. But no matter what your job title, I'm sure we've all had the experience of somebody exporting data, and the way they version it is just by kind of picking a name and the date that it was exported. And then since they exported it multiple times on this date, they decided that V2 was going to be the name of the next export. And then they did a few other changes, and actually it's V2 underscore final. And you might not have had this experience with CSVs, you might have it with PowerPoints or videos or whatever it might be, but the concepts still stay the same. And this could be especially problematic with data because data sets change all the time. Just eyeballing these two, I can't even really see what the difference is until we dive a little deeper. And so that's just a little context for like what we'll be starting with and how we'll clean that up with version control. So a real world example is this COVID-19 diagnostic testing data set. This data was downloaded from healthdata.gov. You can head over there, follow this link, and grab your own example of it. And we can see that the data set was created on December 14th, 2020, and it was last updated yesterday, November 8th, 2023. I actually went there again today, and there's a new version from November 9th, 2023. But the problem is we can only really see the latest version here. And every time I went to download it, they kind of just appended the date to the end of the CSV. And that means there's 3 years of untracked, unauditable changes that have kind of been lost to the sands of time. So that's not great. We saw how you might version your files if you were doing it in a suboptimal way. And this just really doesn't scale as you work on teams. Just because you know why you named the file this, your teammate probably doesn't. And being able to understand how the data changed over time is pretty important. So enter Oxen AI. Oxen is comprised of these command line tools and Python libraries, as well as a web interface for everybody to get on the same page of what's in their data set. Oxen is slightly different than Git. It's able to handle lots of files, large machine learning data sets. But for this example, we're going to stick to a simple single CSV file to kind of wrap our head around what is going on. I already have Oxen installed, but feel free to follow the example there to get it up and running on your machine. And in this case, let's say you're trying to analyze the outbreak of COVID-19, and your team is tasked with collecting data and building predictive models to try to help stop future spreads. You have a data pipeline that exports this data from healthcare or healthdata.gov each night. And since your team is super smart, they've already set up Oxen in the loop to make sure that none of these changes are lost and the whole team has visibility into what is happening. I have a poorly organized version of this data set here that you can go and grab. And what that kind of looks like is what we showed before of, a bunch of the same file, but with different extensions. And we'll kind of walk through how we can organize this into one file with multiple parallel histories and iterate on our data, kind of like we do our code. So let's start by downloading the data, which I already have done over here. The first thing we're going to do is pick a canonical name for the CSV file, the data set itself. And so in this case, I'm going to pick the same name, but without the date extension. So let's just go ahead and copy this file and rename it to this. Oxen built in has some cool data frame functionality. So if you even just want to peek at what this data looks like on the command line, we can see that it has 179,000 rows and 9 columns. It looks like there's a bunch of states, there's a bunch of dates, there's a bunch of numbers of results reported, new results reported, total results reported, etc. So that kind of gives you a sense of what's in the data set. If you're familiar with Git, this will look pretty familiar. You'll do an Oxen init to create your local repository. You'll do an Oxen add on the data file. Oxen status will give you a sense of what files you're about to commit, what files you're about to save into the eternal history of time, and what files are untracked. You'll notice some things like we detected the data schema here. Let's ignore that for now. And let's simply commit this data with a message. So in this case, I'm saying adding the initial data from July 2nd, 2023. And what this does, this first step, decouples your description of what happened to the data from the file name itself. So we no longer have to rely on file names at this point, but this is just the start of the benefits of version control. So now that we've committed it locally, this is all just on my local computer here. Let's share this file with the world and let's push it up to Oxen AI. I already started working on this repo here. I'm going to delete this one and start from scratch so you can see the full workflow. You can make your repositories public or private. We'll keep this one private for now, but if you wanted to make a public resource, you're free to do that within Oxen. And you can kind of follow the steps one for one here. In this case, we've already added some data, so I'm just going to point my local repository to this remote server with this command, and then I'm going to push the data to the remote server with the Oxen push command. So we can see it's kind of gathering up the databases, it's pushing this 10 megabyte file, and voila, we have the data up on Oxen, just this one file, and you can click into it and see a nice, pretty view of the data itself. So that's pretty standard. You could do that with any kind of blob storage system. You could even do that with GitHub if you wanted. But that's not where Oxen shines, just as being a raw blob storage. Where it shines is tracking changes to the data over time. So we're going to take this other export. If you recall, the first one was from July of 2023. We're going to fearlessly overwrite our local file of COVID-19 PCR testing with this new one. If we do an Oxen status, we can see that Oxen automatically detected that this file was updated. And if we do an Oxen diff, we can see it computes, it goes through all those rows, and it's like, whoa, you've added 92,000 rows. You've changed or removed 57,000 rows. This is a big change between July and I guess this is November, right? So this wasn't just a matter of adding a bunch of data that you can see this, it used to stop in July. Now it stops in November. Like there's more of those going on here between those two timestamps. So what we're going to do is add that file again. We're going to give it a new commit message here and say, here's the data from here. And you can even be more verbose than this. It looks like there are a lot of changes. And we can push that back to your cloud service, your cloud Oxen instance. You can see there's a little more data this time than last time, but it is pretty quick to get that data up there. And you'll notice we still have that single file here, but instead of the, I think there was like 170,000 rows, now there's even more. And, I can't even remember from doing that back to back what the changes were. So what's cool about Oxen is you can click into the versions tab. You can see the initial version of the data right here. You can see I added new data right here, and you can click into an individual commit and you can see, whoa, there were a bunch of new rows added, a bunch of rows removed, file changed by 2.1 megabytes. And you can even dive into see exactly what the current version of the file is, what the file looked like before the changes, and then what the added rows were, what the removed rows were, etc. So you can kind of dive in from here to see more information about your data, do some exploratory data analysis, etc. So we talked about the commit history, we talked about looking at the data before and after, but what's really cool is very similar to a Git or GitHub type workflow. You can create what are called branches, and branches are kind of like parallel histories of the same file. And so we're not going to make any changes. We're just going to push up this branch to start, and we'll go back to the data here. It looks like it was pushed. So now what you can see in this dropdown is we have two parallel states of the data set, which is pretty cool. And you can seamlessly swap between these branches in the Web Hub. In this example, I'm going to pretend that I am an engineer who decided that these weren't the column names that I wanted. I think we could actually make them a little less verbose, a little cleaner. And so I've made my separate branches. I'm going to copy over my file that previously was _v2 into the v1. I'm going to add it. I'm going to say I reformatted the data from this date, and I'm going to push this change to Oxen. Pushing the new data should take just about a second there, and we are up and running. We are rolling, and if you look, it doesn't look like anything's changed on the main branch. We switch to the reformatted data branch though, and click on this file. Maybe let's even dive in to the versions and go to the reformatted data branch. We can see we have a new commit here where I reformatted the data. Click into it. You can see 3 of the columns changed. It looks like maybe none of the rows have changed. It's hard to tell yet, but until you dive in, now we can see, oh, look, it looks like I got rid of the geocoded state column. I renamed the new reported or the new results reported to new reported. I renamed overall outcome to outcome and renamed total results reported to total reported. So this is important to know if you're working in a data pipeline, because obviously changing the names of your schema is going to change the code you need downstream to process it. So being able to flag these things in a UI and experiment with them in parallel is pretty important. So we can see all those changes here. What's cool with this, just to kind of close the loop, is now you can grab any one of these individual files. So you can go to the version that has these column names, or, in a new tab, I'm going to open the original version of the file. And you can see, and let's kind of get rid of the highlighting here for a second. But, this is the original version. This is the new version. The file name hasn't changed, but we have two completely different states of the data set in parallel at the same time. And you can use the command line, you can use Python, you can even just use HTTP to download these versions and kind of like kick them off into your other workflows, and really have the confidence to iterate on your data over time, know what changed, and build more robust and reliable data applications. So that was kind of 101, what's version control? How does the Oxen command line tool interface with the Web Hub? If you'd like to learn more, you can see all the command line and the Python commands here. There's a lot more information on each one of those components in our documentation. It's all open source, so you can go to our GitHub and find out more. And thanks for following along. I'd love for you to reach out to us to see what you build, and feel free to give us an old star on GitHub. We've actually set this up so if you give a star on GitHub, it goes and generates you an oxen with wings. And so we can kind of see everybody that's done this. They've gotten their own personalized ox. Shoot, this one didn't have wings, but it had a lot of wild horns. But you get your own personalized ox, which is kind of fun. And yeah, looking forward to see what you build. Thanks so much.